Hi, students. In this lecture, I am going to discuss problems based on torque and equilibrium of rigid body. Let us see first one. A force of 3I cap plus 4J cap plus 5K cap Newton is acting on a rigid body at a point whose position vector is I cap plus J cap plus K cap meter. Find the torque of that force about origin about a point whose position vector is. Okay, let us see how to calculate torque. So first write down the given data. So force is F bar equal to 3I cap plus 4J cap plus 5K cap Newton. It is given this force is acting at a point whose position vector is. Let us take this point as A, then position vector of that point A, that is I cap plus J cap plus K cap. Okay. So we are taking the point where force is acting as A. And other point, let us take it as B. Then position vector of B. Position vector of B. It is a minus 2I cap plus J cap plus 2K cap meter. So first we have to find torque about origin. Okay. Let us see that. So we have definition tau bar equal to R bar cross F bar, right? So first one is about origin. Tau bar about origin is equal to, let us see, I cap, J cap, and K cap. Next, R bar cross F bar, R bar, position vector. It is given 1, 1, 1. Okay. I cap, J cap, K cap. Next, F bar. F bar is now 3, 4, 5, right? And you know how to calculate cross product, right? See how to calculate by leaving the first column. Focus now. 1 J cap cross 5 K cap. Okay. So 1 into 5, it is a 5 minus 1 into 4, it is a 4. So 5 minus 4 into I cap. So why I cap means J cap cross K cap. That is I cap. Okay. Next. Leaving the second column, it is 1 into 5. I'm taking here minus J cap 1 into 5. It is a 5 minus 1 into 3. It is 3. Next, plus K cap plus K cap. Leaving the last column, 1 into 4. It is a 4 minus 1 into 3. It is 3. Now see what is this? 5 minus 4, 1. So 1 I cap. 5 minus 3. It is a 2. Minus 2 J cap plus K cap. This is now torque about origin. Okay. For example, if they ask what is a torque about x-axis? Okay, so this is a torque about a point. Now question is torque about an axis. Suppose a torque about x-axis. That means we have to take component of a torque about x-axis. That is 1. Okay, how much it is? It is 1. Torque about x-axis. Nothing but component of this vector along x-axis. That is 1. If they ask in the same question, what is a torque about y-axis? It is -2. Or you can say 2. Direction is along negative y-axis. Okay. If they ask a torque about z-axis, it is 1. Okay. And direction is along positive z-axis. So whenever they're asking torque about an axis, so simply we have to focus component of torque, right? Okay. Now we have to focus a torque about point B. Okay. Then see what happens. Torque about B is equal to. So now we have to focus position vector of the point of application of force with respect to B. So this becomes now position vector of A with respect to B cross F bar. Okay, it is simply shifting the origin, shifting origin to B, right? Then see what happens. I will write here position vector of A with respect to B. That is equal to RA bar minus RB bar. Let us see how much we get. R, R, RA bar minus RB bar 1 minus minus 2. It is 3. 3 I cap j cap minus j cap. It is 0. Next k cap minus 2k cap. It is minus 1 minus means minus k cap. Cross check once. I cap minus 2 I cap. 1 minus of minus 2 plus 2. So plus 3 here. J cap minus j cap is 0. 1 minus 2. It is minus 1. Now see the calculation. Again, same process. Only changes here position vector of the point of application of force. Already we have discussed that torque depends on about which point we are calculating. So it is I cap, J cap, K cap, R bar 3, 0, minus 1. Okay. Coming to F bar, no change in that. 3, 4, and 5. And remain just calculation part. So it is leaving the first column 0 into 5, 0 minus 4. Okay, I cap. Next, leaving the second column 3 into 5. So I'm taking here minus j cap. So why minus j cap means 3 5s means 3 I cap cross 5 k cap. Okay, I cap across k cap. It is minus j cap. That's why here minus j cap. 3 5s 15 minus 1 into 3. It is minus 3. So leaving the second column 3 into 5 15 minus 3. So minus 3. Next plus k cap. Leaving the third column 3 4 12. 12 means 3 I cap cross 4 j cap. I cap cross j cap. It is a k cap. Okay. So 12 k cap minus 0 into 3, 0. So it is now 4 I cap. Next, 15 minus of minus plus 18 minus 18 j cap plus 12 k cap. Okay. Again, the same way. If they ask what is a component of torque along x-axis, it is a 4. Direction is along positive x-axis. Okay. If they ask component of a torque along y-axis, it is 18. Direction is along negative y-axis. Component of torque along z-axis, it is a 12. Direction is along positive z-axis. Okay. See next one. A heavy wheel of radius 20 centimeter and weight 10 kg is to be dragged over a step of height 10 centimeter by a horizontal force F applied at the center of the wheel. The minimum value of F is, so condition given, heavy wheel, radius given, weight is given, and a height of the step 10 centimeter, horizontal force F at the center of the wheel. We have to find minimum value of F. Let us see how to start it. First of all, make a diagram for the given data. This is now sphere. It is sphere. Applying force horizontally, and that is passing through center. Applying force here. Now there is a step, okay? Suppose this is now step, right? See, condition is that when we apply force horizontally, this sphere has to rotate about this contact point, because when this is about to move on to the next step, losing contact at this step means you can say at this point. So when this is about to roll on to the next step, the only contact is now with the edge of the step. You can see here, it is having contact only with the edge of the step. That means, okay, this point. Okay. Now see the condition for this to move this sphere on to the next step. Say force is acting on the sphere, mg, applied force, at this contact, frictional force and normal reaction. At this contact, we are not taking any force. Relation is, it is about to move on to the next step. So losing contact here. And we are taking torque about this contact point. Okay, about this point. In fact, this is not a point. It is actually one axis, right? It is one line. This step, isn't it? It is a step, one line. So when you take about this one, because of applied force and because of normal reaction, torque will be 0. So about this, because of applied force, torque will be, it is a clockwise. I am repeating, because of applied force, about this axis, torque is clockwise. About same axis, because of gravity, torque is anti-clockwise. So condition is now, torque due to applied force, if it is greater than or equal to, means if you focus modulus value, greater than or equal to torque due to gravitational force. If it is equal, about to move on to the next step. If it is greater than, it moves on to the next step, right? He's asking now minimum force. Minimum force means just about to move. So taking limiting case, means equal to, right? Now see carefully the values given here. Radius equal 20, R value 20 centimeter, height of the step 10 centimeter. Now focus here F into, see what is perpendicular distance. You just imagine the line passing to this point parallel to force, okay? So like this. This is now separation, okay? Which is equal to 10. That is 0.1. If it is equal to EMG. And we can say mass is given as a 10 kg. So 10 into G, that is weight. Coming to perpendicular distance. You can see perpendicular distance means, let me take this as point A, contact point, and this is a point B. We have to find AB, okay? Suppose center is now C. You can see AC is now radius. AC is radius. We want AB, okay? Then see what is the value of AB? AC square equal to AB square plus BC square. AC square 20 square, that is equal to AB square, that we have to calculate. BC square, it is now 10 square, right? Because from C to up to here 20, this is now 10, so remaining is now 10. That means AB value 400 minus 100, 300. It is now 10 root 3. AB value, it is now 0.1 into root 0.1, 0.1 gets cancelled. So F equal to 10G, right? Into root 3. So we can write 10 root 3 kg weight. Kg weight means into G. So this is a minimum force. That means if a force is slightly greater than 10 root 3 kg weight, then it will move on to the next step. Okay. Let us see next one. Let's see the problem given. A vehicle of width A and its center of gravity at a height h is it taking turning on a horizontal road of radius of curvature r. So given vehicle, its width is a, height of center of gravity is h, taking turning on a road which is a horizontal. Its radius of curvature is r. Find the maximum speed of the vehicle so that it can take turning safely without overturning. Okay, let us see how to solve it. Let us take, suppose now this is a vehicle. Just imagine we are seeing from the back. Okay, na? So we are behind the vehicle. Just assume it appears like this. Okay, and let us take turning is now left side. It turns left side like this. In that case, if we want to solve from the vehicle frame, it becomes now non-inertial frame. Okay, then we have to take pseudo force. When this is a turning left side like this, turning left side, then pseudo force will be outwards. And you can see that vehicle overturns about outer wheels. So if you observe, whenever we are going in a vehicle, taking a turning like this left side, if speed is beyond a limit, it will overturn about outer wheels. In this diagram, these are now inner wheels, and these are outer wheels. That means overturning will be outwards, means about outer tires. That means overturning is about outer wheels means torque will be clockwise. Okay, let us see here. This is now centrifugal force mv square by r. Its a height is given as h. Okay, weight mg, that is now vertically downwards. Between the tires, you can say given width of the vehicle equal to a, right? So not to overturn condition is I am taking about outer wheels torque equation about outer wheels because vehicle overturns about outer wheels only. So in that case, about outer wheels due to pseudo force torque will be clockwise. Okay, due to pseudo force torque if it is less than or equal to torque due to gravitational force. Equal to means about to overturn. Less than means there is no overturning. Okay. This is now condition. So I'm writing here torque due to pseudo force. Or if you have confusion, take here in the place of S P. P stands for pseudo force. So torque due to pseudo force. Right now see carefully. It is mv square by r into h, that is less than or equal to due to weight mg, torque is mg into, this is a half, right, midpoint. So mg into a by 2, m gets cancelled, v value less than or equal to r g a upon 2h. This is a value of v. That means speed should not cross root of rga upon 2h is a point left. And from this we can say if width is more, speed can be more. If a center of gravity is less, height of center of gravity is less, speed can be more. For example, if you observe an auto is taking a turning and a bus is taking turning. Compared to auto, bus is having more width. That means bus can take turning with a more speed compared to that of auto. Okay. That means more is the width, more is safer, more safer. Next, height. If center of gravity height is less, it is more safe. Suppose you are taking a lorry which is carrying heavy weights, okay, and you are taking a car. Center of gravity of car will be at less height compared to that of lorry. Means car can take turning with a high speed, right? Means if we assume that both are having same width, if you are taking width is the same for both, then we can decide only basing on height, right? Let us see next one. Okay. So these two questions basing on equilibrium of rigid body. So the first one, a uniform rod of length L and mass m is leaning against a smooth vertical wall. Find the angle made by the rod with the horizontal when the rod is about to slide. Uniform rod length L mass is m, given wall is vertical and smooth. Angle made by rod with a horizontal when rod is about to slide. Right, let us see. Let us make a diagram. So we have learned that if a rigid body is in equilibrium, then net force equal to zero, net torque equal to zero. Okay, let us see now. So rod is now leaning against a vertical wall. Given wall is now smooth. This angle made by the rod with horizontal we have to calculate. That is theta. Let us take now free body diagram. Let us take vertically up as positive axis and a horizontal as x-axis. From ground, normal reaction from ground, normal reaction from wall, its weight mg downwards, which is a passing through center of the rod because rod is uniform and it is a contact. Frictional force will be left side and condition given that it is about to slip. So friction is now limiting value. Okay. So let me take now net force equal to 0 along x-axis and along y-axis. So if you take net force along x-axis 0, that implies along x-axis. Normal reaction from the wall should be balanced by frictional force, right, by ground. So horizontally net force equal to 0. Coming to vertical, normal reaction from ground should balance mg. So net force along vertical is 0. Okay. So what we can do here, normal reaction from ground that is equal to mg. Right. See number of unknowns, normal reaction from wall, from ground and limiting friction. And we know limiting friction equal to mu s into normal reaction. It is from ground. Okay. Next, we can see net torque equal to 0. And we have learned one important point in the last lecture, that is, whenever net force on a rigid body is 0, net torque will be same about any point. Now in this, we can take net torque about any point. It is our choice. Let me take this as origin. This is A and this is B. So we can take about any point. So now here what I'm doing is I'm choosing a point so that more number of forces are passing through that point. Then because of those forces about that point, torque will be 0. So I'm choosing now point. So due to normal reaction from ground, frictional force, torque will be 0. Now it is only because of mg and normal reaction due to the wall about A. Because of mg, torque will be anti-clockwise. See carefully about point A. Because of gravity, torque will be anti-clockwise. About A, because of normal reaction from wall, torque is clockwise. So torque due to normal reaction from wall should balance, means modulus value. Torque due to gravity. So normal reaction from wall into perpendicular distance, and that is equal to OB. OB means it is L sine theta. See carefully, force into perpendicular distance. Okay, that is equal to torque due to mg. So mg into perpendicular distance in this case. It is now L by 2, L by 2 cos theta. So just imagine a line passing through point A parallel to MG. Then between this line and between that line, separation equal to L by 2 cos theta. So L gets cancelled. L gets cancelled. So in the place of NW, see what I can write? What I can write? FL equal to mu S into mg. Substitute that here, mu s into mg into sin theta, that is equal to mg into cos theta by mg gets cancelled. So tan theta is equal to 1 by 2 mu s. So theta equal to, it is tan inverse 1 by 2 mu s. Students, you have to focus in mind. This is this rod is in equilibrium. That's why net force zero, net torque zero. So taking both the conditions. So we've got here totally three equations. So two force equations along x and y and one torque equation. And remaining is now just the calculation part. Right? So I hope you got clarity.